My name is Jalen Camacho, and this is the Newton's Laws of Motion project for Coach Padron's class, third period. Today is December 19th. This is going to be demonstrating the first law, which is an object in motion will stay in motion unless acted on by an unbalanced force. An object will not change its motion unless a force acts on it. An object that is not moving remains at rest until something pushes it or pulls it. All objects resist having their motion change. This tendency to resist change in motion is called inertia. The more mass an object has, the greater its inertia. So, right now, the line is going to be the thing at rest, and the inertia is going to stop it from moving. And these are going to be the thing in motion once I hit it with my hand. Newton's laws, second law states that a change in motion occurs only if a net force is exerted on an object. A net force changes the velocity of an object, causing it to accelerate. If an object is acted upon by net force, oh, before I do that, I'm gonna do one more of the first one. This is glass of water, obviously, and a piece of cardboard, and I'm gonna try to take it out without it moving, because I'm not taking on that. Alright, that works somewhat. Let's just burn. Newton's second law states that a change in motion occurs only if a net force is exerted on an object. A net force changes the velocity of an object, and it causes it to accelerate. If an object is acted upon by a net force, the change in velocity will be in the direction of the net force. The acceleration of an object depends on its mass. The more mass an object has, the more inertia it has. The harder it is to accelerate. More mass means less acceleration if the forces acting on objects is the same. That demonstrated that since the ball had more mass, it was able to knock down the dominoes, and it also moves the dominoes in the same direction. The little piece of paper doesn't have a lot of mass, so it won't be able to knock down the dominoes like the baseball. I mean the dominoes. The straw is demonstrating that, well, the wind that my mom's blowing out is going to be the net force, and the napkin is going to be what it's pushing. So she won't have to put so much pressure on it for it to work. This is Newton's second law. For the third law, which states that for every action there's an equal and opposite reaction. Where one object exerts a force on a second object, the second object exerts on equal force in the opposite direction of the first object. The force exerted by the first object is the action force, and the force exerted by the second object is the reaction force. The ball bouncing demonstrated that whenever the ball hit it, there was an opposite reaction and it bounced up. That's action reaction. As you can see, my mom is pushing the counter, but it's not moving because the wall is pushing back with a greater net force than my mom is. This concludes the third law, I mean, and